In our last lesson, we dealt with solving and graphing exponential functions, and we already know that exponential functions and log functions are inverses of one another, so now we're going to do graphs for logarithmic functions. We'll graph them and then do domain and range and y-intercept and all the same stuff we did with the last one. So first thing that you need to know about log functions, here's your parent function, f of x equals log of x, so no changing bases, nothing added or subtracted, just basic. Its x-intercept is 1, 0, and a vertical asymptote at x equals 0. And that is the y-axis, so it's this line right here. And so the graphing calculator makes it look like it starts here, but it doesn't actually. And remember, that's all related to the pixels. So it actually just keeps on moving downward and getting closer and closer and closer, but it's not going to touch that line. Using the transformations, oops, let me go ahead and shift this over a little bit. When we're using the transformations on these functions, we have a couple of things that happen. So our a term out here, it can make the graph open faster or slower. And so again, that comes back to the same thing like it did with quadratics and with exponential, if it's a whole number or if it's a fraction. If it's negative, then it's going to flip upside down. And then in this one, we don't have any graphs that are going to flip vertically over the y-axis. They're just going to flip horizontally over the x. We have this base number down here, and that's going to change with each graph that we do. And we have two instances. We are going to have a b value that's greater than 1, which means you have an increasing function. And then again, that depends on your a value. Or it can be between 0 and 1, in which case the function is going to decrease. We have our h and k, just like every other function we have done this year. That is our starting. We start at 1, 0, and then we're going to shift left and right, and then our k is shifting up and down. And remember, change the h, keep the k. And the h is the number that you use for the vertical asymptote. All right, so a couple of things when you compare these two functions, since they are inverses, remember how the inverses swapped x and y? Well, since the exponential started at 0, 1, our logarithmic starts at 1, 0. Our exponential had a horizontal asymptote and our logarithmic has a vertical. Exponential, the domain is all real numbers, and in logarithmic, the range is all real numbers. So everything is flipped. And that's what kind of helps you remember everything, because if you can memorize these three things here, that'll help you get those because all you have to do is change it all. So let's go ahead and do a couple examples and make these graphs and find all the information needed. So let's start with first identifying our a term. So our a is 3, which means since it's positive, so positive means it's going to increase. Then we move into our b term. Our b term is 10, and 10 is greater than 1, and so that sticks with the fact that it's going to increase, so that's good. This one right here is our h, but remember we changed the h, so that's a -1, and there's nothing added or subtracted outside, so k is 0. So normally our starting point would be 1, 0 right here. However, the h shifts it to the left 1 and down nothing. So our starting point is actually going to be here. Now remember, this h also gives you the asymptote, so it's x equals -1. And you should go ahead and put a vertical line at -1, a dotted line, to show that that is the asymptote. It's a little hard to do on here. And then go ahead and make your graph. And we don't really need to get any more specific. That looks kind of bad. We don't need to get any more specific than just drawing both ends out and kind of like that. We know that our range is going to be all real numbers because it extends upward and downward forever. So again, that's -infinity to a positive infinity, doing our interval notation. Our y-intercept, we actually graphed it, so we didn't really even have to do anything. It is 0, 0. However, if you're looking for your y-intercept, you just plug in, so plug in 0 for x. Okay, so that's all you're doing to find that intercept if it isn't already explicitly pretty much given to you on that in the graph. And then we do our domain. Well, domain is going to be based on where our asymptote is. So our h, our domain, our asymptote all go hand in hand. So x, such that x is, and we're using all the numbers greater than -1, so greater than -1, which means we're starting at a -1 and going off until a positive infinity. And we use parentheses because it's never actually going to be -1. Example 2, we have a couple of different things happening here. First, you'll see that we have an h value of 2. We've got a k value. Remember, keep the k, change the h, so -5 we keep. And then we have this 1/4 right here. Well, what does that 1/4 do? Well, here's your a term. And what that is going to do is it's going to stay increasing, but it's going to go slower. It's not going to go as fast. And if we got more specific and plugged in values, we would see just how slow it moves, but we don't really need to do that. We don't need to get too specific. All right, and then our 1/2 here. Well, our 1/2 is between 0 and 1. And what does that mean? That means that it's going to decrease the whole time. So even though this was a positive number here, this being between 0 and 1 is what's going to make it decrease. Okay, so our starting point normally is at 1, 0 for these graphs, but our h says to shift it to the right 2, so we go over 2 and then down 5. So we go down 5 and right here is going to be our starting point. Now remember that this h value is also your asymptote, so x equals 2. So we're going to go ahead and put in a vertical line to show, or vertical dotted line to show that this is our asymptote. It is going to be decreasing, which means it's going to go downward like this. So what that means then is this is going to go out this way, and this side up here is going to come up close to, but not quite touch that horizontal, or that vertical asymptote there. You'll notice that there's no way for us to cross that line. It's never going to hit the y-axis, so we don't even have a y-intercept to worry about at all. Our range is still all real numbers, -infinity to a +infinity, and then our domain is x such that x is greater than 2. And then that would be 2 until a +infinity. And again, that's coming from the 2 as your h value, the 2 as your asymptote, and the 2 is used in your domain as well, which is all the exact opposite of what we were doing with our exponential functions. And now let's go ahead and look at one that has a negative. So this -a value, so a is negative, which is going to make it decrease the whole time. And so it's going to kind of go downward like that. This number right here, your b, is greater than a 1. And so what that means then is we're going to let this negative take over. Now, this x right here, there's no parentheses on it. This -4 is not grouped with it. So this -4 is your k, okay? And it's because, I'll even write, it's not grouped with the x. So it's really important that you notice that there's no parentheses around those two numbers, which would mean then that your h value is 0 because there's nothing here with the x. So again, we're starting at our intercept of 1, 0, and then we're not shifting it left or right at all, but we are shifting it down 4. So we go down 4, and this is going to be our starting point. But we need to put our asymptote in here. So our asymptote is happening at this value here, which would be x equals 0, which is the line right here on top of the y-axis. So if you're doing this on the paper, sometimes kind of scribbling back and forth a little bit is helpful. And then we need to draw it. Well, we have a decreasing function this whole time because of this negative, and so we're going to decrease this way. It's going to go out that way forever, and then come up this way and kind of brush up against the asymptote, but never actually cross it or touch it. Because of that, and the asymptote being where it is, we don't have a y-intercept, so none for the y-intercept. And again, if you just plug in 0, you would see that it's not actually going to work. The domain, when we go to write that, we're using our same value as our asymptote, so x such that x is greater than 0, which would mean 0 to infinity and parentheses on the 0 because it's not actually going to touch it. And then the range is your all real numbers, which means -infinity to a +infinity. So there are your graphs. Now in class, we are going to go over a couple of other things that are very calculator based, so you need to have that on you, and just make sure you have these and any questions, and we'll be good to go.